Hello, everyone. Welcome. Thank you all for coming. It's a real pleasure to be here. So today, I wanted to talk to you about three things. The first one we're going to talk about is events. This special kind of data that kind of moves through a company. I also wanted to talk about stream processing. That's really the ability to deal with these real-time data sets, to process them, to turn them into new things. But mostly, I want to talk about databases and how the concept of a database relates to this world of data that's actually in motion, that kind of moves around your application, that moves around your architecture. But before we get to that, I'd just like to start by thinking a little bit about our industry and some of the trends that have flown through it over the last 10 or 20 years. So this guy called Mark Andreessen wrote a blog post back in 2011. And this was actually pretty pivotal. It kind of underlined a kind of big trend in our industry. In some ways, it's quite a simple trend. His synopsis was that software is eating the world. And this insight, which is actually fairly simple, actually has a lot of implications. It leads to a lot of the big trends that we see today. It leads us to things like the ubiquity of mobile communication, the Internet of Things, machine learning. All of these big trends come from this idea of software eating the world. And Mark's, he kind of runs a venture capital firm in the Valley. And obviously it's his job to kind of predict these trends. So the synopsis of this is, as I said, fairly simple. It's that basically, as businesses grow over time, they're going to consume more software. So if you invest in software, then probably that's going to be a growth area. It's a very simple idea. But actually, if we think about this idea more clearly, or more specifically, there's really two forms. So there's a kind of a weak form of this, software is eating the world. And in the weak form, companies buy more software. So, for example, you might work in a company and they might decide to buy Slack. Right? So Slack is a communication tool. You can install that in your company and everyone will kind of hopefully communicate better. So maybe not just using email, they'll also use Slack. You've kind of consumed more software. The company works better, so maybe it makes more money. So that's kind of a good thing. That's kind of the weak form. Over time, we, as individuals and companies, will consume more software. But there's a stronger form of this thesis. And the stronger form is that not just that we will consume more software, the stronger form is that actually businesses are going to become defined in software. Businesses are actually going to become software. So that seems a little bit abstract. So let's take an example. So imagine you want to get a loan, right? So maybe something like a mortgage. Right? The process for getting a mortgage has been the same for many years. In fact, it's been the same since before computers were around. You have like a borrower who maybe goes to a bank and fills in an application form for a mortgage. That would then, in the days before computers, that would kind of be sent in some kind of memo through the internal mail to the credit officer, and he'd check to see whether or not he thought you were creditworthy and were actually a good person to lend money to. And maybe that would then be sent to the risk officer, who would make sure that the bank wasn't taking on too much risk lending you this money. And the process that we go through to do something like getting a mortgage, it's like pretty much the same today. And maybe you phone up your broker, and your broker kind of enters the details into some web form, and then that goes to a back-end system, and then the credit officer maybe has like a specialist program which helps them evaluate your credit by looking at your credit history and things like that. So there's a sort of this trend is definitely happening. Like, so we've gone from a manual process to one where we're actually enabled by software. The credit officer has a specific piece of software which helps him do his job. Likewise, the risk officer. But the process is actually pretty much the same. So this is like the weak form. This is the company consuming more software. And in this kind of model, things are still relatively slow. If you go and get yourself a mortgage, it maybe still takes like 1 to 2 weeks for that to happen. And maybe that's okay, but there are other vendors out there that'll do this much quicker. And they do this because they really implement the strong form of this idea of software eating the world. The strong form being the one where the whole process is defined in software. So rather than having like a credit officer specifically in the workflow for this mortgage application, we have a bunch of services. We're automating this process. So the credit officer is actually now a credit service, and there's a risk service, and there's a CRM service, and they talk to one another. Software is talking to software. And in this kind of architecture, you can actually go and get a loan in a matter of a few seconds. And the interesting thing about this type of process is that it's always on, right? So you can, software doesn't take a break to go and have a cup of tea. It doesn't go home at the end of the day. You can get a mortgage application at 3 in the morning. If the whole process is defined in software, and the actual process itself doesn't take 2 weeks, it takes a few seconds. Of course, there are people involved. There's still a credit officer. Right, but the credit officer isn't managing the core workflow. They're sort of managing the exceptions. If maybe your credit rating can't be evaluated correctly by the program, then it will get pushed to this credit officer who would do it manually. But the core workflow is primarily defined in software. So this is this strong form. This is this form where we take business processes and we actually wholly define them in software. So what's interesting about thinking about this transition as we move from this weak form to this strong form is that it actually changes the nature of the software that we build. So in the weak form, we're building programs or applications which are designed to help end users. So maybe a program that helps the credit officer, and that'll have like a user interface because they need to interact with the program. It'll have maybe a back-end service that does the logic and the database that sits at the back. But in the strong form, the architecture is actually very different. There's actually no user interface here. These are just automated services which are talking to one another. So the credit service talks to the risk service, et cetera, et cetera. So this is a very different style of architecture and actually needs to be architected in a slightly different way. And a good example of this sort of change to fully automated workflows is something like ride sharing. Like traditionally, if you want to get a taxi, I actually ended up calling a taxi to get here today because I lost my keys. So traditionally, you would phone up your taxi company, and maybe they'd enter your details in the system and kind of radio around to find you a taxi to come to your location. But if you use like a ride-sharing application, there's actually no person involved. So in the taxi example, the taxi operator is being aided by a software program, but you use something like Uber or Lyft, and actually the whole process is defined in software. At the back end of Uber or Lyft is lots and lots of microservices that are talking to one another, and data is flowing between them. There's streams of data coming off the phones on the customer side and on the driver side with like GPS information that tells them where you are. If you order an Uber, that's then going to broadcast that business event that you want something to a whole bunch of nearby taxis. Maybe in the locality, one of them might reply, and maybe that'll be accepted. Maybe actually another car will accept slightly later and is actually slightly nearer to you, in which case that one might be preferred. So in this world where we're actually defining whole business processes in software, we're able to actually innovate a little bit better. So we can provide solutions which are actually better for our customers, as well as being always on, as well as being very scalable, able to run in different locations because you're just able to move this software from place to place. But the fundamental thing that's worth highlighting here is that in this strong form, where business processes are wholly defined in software, the user of the software isn't a person anymore. The user of the software is actually another piece of software. So the software we build needs to be designed not for us, but for dealing with some other program. So I want to reflect a little bit on what that means for databases. So just take a moment, close your eyes. Actually, you don't have to close your eyes, but maybe figuratively close your eyes and just think about what a database is. Like most of you will have used a database at some point. You will have written programs that use a database, or maybe explore data in a database. What is it? What is it? What does it feel like to use one? What's the image that comes to your mind? Well, for me, it's something like there's some server off in the distance somewhere, and it's got a lot of data in it. In fact, it's got so much data that there's no way that I can understand it. There's no way my mind can parse all that data. There's numbers and bits of text and dates and stuff. And I've got no way of really understanding all that. But I have this query language. And in this query language, I can ask a question. And I can format that question in a syntax which will get me what I want. I can send it over to this database, which is off in the distance, holding this kind of passive data set. And I can get an answer returned back to me. That's what I think of when I think of a database. Maybe you think of something similar. And actually, databases have taken this form since they were first invented. The first ever database, the first commercial database was IBM System R back in 1973. And actually, that form of database has progressed. It's been very successful. Databases are some of the most successful programs that we've ever written. So Postgres is actually, in many ways, an ancestor of Ingress. Anyone use Postgres? Yeah. So that's sort of an ancestor of Ingress. That's actually an ancestor of System R. The form is very much the same. And today, we have hundreds of different databases. Loads of different varieties. They've all got little specializations. So Cassandra's very good at storing lots of data on disk efficiently. It has a indexing structure that's well suited to that. Neo4j, that's a database with a special query language which will let you not just query entities, but the relationships that exist between them. Elasticsearch has very advanced indexing structures, so you can ask complicated questions and get very efficient answers because of the way it indexes your data. We have hundreds of these different types of database, but they all take one form. They all take actually the same form, give or take, to the database that was first released in 1973, IBM System R, and actually probably the database that you thought about when you figuratively closed your eyes. The fundamental assumption that all databases take is that data is passive. That a database is somewhere that you put data and it just kind of sits there until you decide to ask it a question. And that's something that I'd like to think about a bit. So fundamentally, databases are designed for you. They're designed to help you answer questions over a data set that you can't understand on your own. That's what they were originally designed for. That's their original form. And that's what they are today. So the question I think this leaves us with is if we think about this transition where we're moving from where software's eating the world and there's that weak form and that strong form, the weak form where we're really enabling users to do their jobs better, but in the strong form, we're actually creating programs where software is talking to software, where the user of a particular piece of software is not a person like you or I, it's another piece of software. Do we still need a user interface? Do we still need our interactions with data to be synchronous? One alternative to this is to use event streams. Right? Event streams are a very different way of representing data. An event is a piece of information which is recorded in the world. It could be you coming in today. It's like a time series of things that happen, all emitted, recorded in real time, and broadcast to different parts of an application or different parts of a company. So it's kind of an implicit motion to this notion of events. And if we can build things like this loan application entirely using events and event streams. The format's still the same. We still have a loan service. We still have a credit service. We still have this risk service. But instead of making calls to one another or displaying things on user interfaces, the programs talk to one another through these streams of events. They're collecting information around the world. That could be from around the world. That could be people creating applications for a mortgage and then creating new events every time a piece of business processing is done. And these things can run sequentially, one after the other. They can run in parallel. And this kind of idea of using events is not just applicable to individual applications like processing a mortgage. It actually works for anything where software is talking to software. If you look at the architecture of a company, that is a bunch of programs talking to a bunch of other programs. Some of them could be databases, some of them could be applications. These are all pieces of software that need to communicate with one another, and that's where an event streaming platform fits in. It sits at the heart of a company. It's like a kind of central nervous system which connects all of these applications together and allows data to flow, allows data to be processed and materialized. So let's just think for a second about what an event streaming platform is. At its heart is Kafka. That's pretty much the foundational technology. There are others, but it's generally the foundational technology in most of these event streaming platforms. But Kafka is actually a pretty low-level interface. Right? It's really, if you're going to compare Kafka to any other piece of technology, from an architectural perspective, from a technical perspective, it would actually be a distributed file system. Very, very similar. Kafka stores events, messages on disk. It appends them onto the end of what is effectively a distributed sequential file. But it's obviously designed for pushing data, not for just storing it. So a file system is designed for storing data passively when you might come back to it later, whereas an event streaming platform is designed for pushing data to different places. But the actual core architecture is very similar. It's storing data, it's distributing it across a number of different machines. And it's a very low-level interface. Like if you were going to build a web application that maybe has allows people to access their shopping cart, you could store the contents of the shopping cart in a file, but you probably wouldn't. You'd probably use a database. You'd use a database because the database provides you with this really nice API that lets you understand data. It just makes it easier for you. And the same is actually true in stream processing. The same is true in event streaming. Kafka provides this very low-level API, but the thing that sits on top of it is actually a stream processor. That's where we use something like KSQL. KSQL is a SQL engine that sits over a distributed log that sits over Kafka. In much the same way that a database is a SQL engine that sits over a file, or maybe a file system. So architecturally, these two things are quite similar. But are they really similar? Does anyone use KSQL? We've got a few. So did it feel like a database when you used it? Sort of. Well, actually, it's really kind of a different thing, a little bit different. And the main reason is this notion that data is moving. Like using KSQL is much more about dealing with data that's actually moving through your architecture. You have input streams, you're processing them, and then you're creating output streams. It's a continuous query, which is running all the time over these infinite streams of events. So I just want to focus a little bit on what that really means. So in a traditional database, what we have is an active query, which is passed to a passive data set. But event streaming is very different. In event stream processing, the data is active, and the query is actually passive. What does that really mean? Well, this is really about what triggers things to happen. In a database, you trigger things to happen. You're the person who's requesting the contents of your shopping basket. You're triggering an active query to find out an answer, to answer a question over a passive data set. In event streaming, it's the other way around. In the event streaming, it's the data that's active. It's the data that's triggering things to happen. And the query is just passively sitting there processing things. This is kind of a fundamental difference. So the traditional database is kind of well designed for user interfaces, for us. And actually event stream processing is better designed for software that's talking to software. The other big difference is the data structures. So databases have tables. Anyone who's used a database will understand that. I can collect data inside a table. If I want to change Jay's credit score, I can just do that. I just update that value. I can change Jay's credit score to maybe 696. Stream processors also have this concept of tables. They're just an implementation detail. You can't see them. But they have this primary concept of streams. That's an append-only data set. So if we look at what a stream is, a stream is really just an immutable sequence of facts. And when we use a stream processor, we create a function in SQL, which is going to do some kind of transformation. In this case, we're calculating credit scores. So we've got like a little function that calculates the credit score for each of these payments that's coming in. And that's stored inside a table. So for each user, there'll be their credit scores. That's the output of that processing. But a stream processor doesn't directly expose you this table. The stream processor exposes you the resulting event stream, every single change that happens to that table. And there's a very good reason for that. If you want to connect software together, actually that software wants to be told about what happened immediately. So you want to have these changes which are coming out of a table so that you can trigger new processing, because in the software-defined world, it's actually the data that's active. You want things to be real time. You want to be able to chain things together in real time. So a stream processor, we're actually bringing a stream in, we're materializing a table inside, and then we're creating a new stream, which is the output. So that's how we can build software that talks to software. That's a good architecture for building software that talks to software, and in a way that's data-centric. But we still need things to be synchronous. We still need user interfaces. We still need to be able to ask questions and get a response. And that's not actually just for users, right? Maybe you want to check to see whether or not, someone's allowed to see this piece of data or something like that. There's lots of use cases where we still need these synchronous APIs. So we might want to have a query, a pull query. What's Jay's credit score right now? Give me the answer. We might also want to have this push query. This is what we normally end up having both of these in our architecture. How do I get a constant stream of events out of this push query? How do I get a constant stream of events out of this table? And we do this by stitching together different technologies. We have a database, which is very good at answering these questions, and we have a stream processor, which is very good at doing push queries. So what we end up doing is having to stitch all these pieces together. Well, we can extract events from various different event sources. We store them inside something like Kafka, which just pushes them around an architecture. We can transform them into different forms. We can load them into a database, and then maybe we add a query. This is a relatively complicated process. We have to, the teams that run these things have to deal with all of these different parts and sew it all together. So the final question I want to ponder is, can one database solve all of these problems? Can it deal with this streaming data and these queries all in one piece of technology? Can it help us stitch together these various different moving parts that extract events, process them, allow them to be materialized, allow them to be queried, but also allow them to push them to new applications? Well, this is what we've been working on recently. And this is the sort of new evolution of KSQL. In this new type of database, you can do two things. Firstly, you can stitch together a whole pipeline. You can suck all the payments out of a database, you can push them into Kafka, you can create a stream which is going to extract every single change which is subsequently made to that database. You can materialize that in a table using a function, which is actually taking a different form. So here the table is the credit scores, whilst the input was a stream of payments. But now that table is not just an implementation detail, that table is something that we can see from the outside. That table is something we can run SQL against. So we can both send a query that answers a question, as well as listen to a set of event streams. You have both this pull and push model all inside one piece of technology. And we call this thing an event streaming database. It can deal with the sort of problems that we talked about before, where we want to answer questions. Users want to answer questions about data, but it can also deal with this problem of pushing data from a table or some one application to another application based on a query, based on some query that we define that's actually going to push just the information that we need to some other piece of software. In this case, maybe this like a automated credit manager. So whilst this is a new type of database, we still need all these other ones. We still need Cassandra for its ability to store lots of data on disk. We still need Neo4j for its ability to query relationships, not just entities. We still need Elasticsearch for all of its great indexing structures. In fact, if we use KSQL, because it can span the whole flow, it can extract events, materialize, do processing, and actually push that data into different destinations, we can use these other database technologies if we want to. We can push data into them to allow us to run queries. We can do that very simply because everything is inside a single API. So we still need all of these databases. But what the event streaming database really provides is kind of like another specialization, just in the same way that Cassandra specializes with data on disk, et cetera, et cetera. This is a database that specializes in event streams. It specializes in real-time data and allowing you to get access to real-time data, to materialize it in tables which you can understand, and importantly, output that information not just as a kind of pull query, but also as a push query, which we can use to connect software to software. So I started this talk by introducing this idea of software eating the world. And really that there were these two forms, this weak form where we as companies just consume more software. But there was this strong form where actually software is talking to software. And that is actually becoming the dominant architecture. It's certainly in all of the big natives, the Netflixes and the Ubers, etc. The core point being that the user of software in this new world is actually not you or me. It's another piece of software. So if you think back to what you thought about when you maybe figuratively closed your eyes and thought about what a database is, the thing I think you need to question is that perception actually in some way biased to you? Is it a perception that's biased to our way of thinking about what a database is because we think about it as us, as people interacting with data? When actually, in this new world, what we really need is a database that is designed both for us, but also for software that's talking to software. And that's all I wanted to say. Thank you very much for listening. This new streaming database is coming out later this month. So if you want to find out a bit more, you can look at those two clips. Those are public on the internet, and yeah, we're very excited. We think this is going to be an entirely new category of data infrastructure. Thank you very much for your time.